Okay, let's welcome Ebin. So he's a program analyst at Cognizant Technology Solution, and he'll be delivering us a hands-on session on integrating generative AI for comprehensive exploratory performance testing. So it's over to you, Ebin. The stage is all yours now. Thank you.
So hi everyone. I'm volunteer.
Hi, Bin. Your voice is little down.
Yeah. Give me a minute. Am I clear now?
Yes, little better. Maybe you can speak a little louder.
Yeah. Or else give me a minute. Is it better now?
Yes, Ibin.
Okay. So let me share my screen first. The image being visible to everyone.
Yes, it's
Yes.
Okay. So as Payal gave me an introduction, I'm Ebin. I'm working as an program analyst at Cognizant Technology Solutions. And I have 1.5 years of experience in the field of performance testing. And I have done some Gen AI stuff and source code, etc. So today I will be explaining what is generative in AI when it is integrated with the exploratory performance testing. So let me move on to the next screen. So exploratory performance testing is a fascinating process. It's about uncovering what's beneath the surface of an application performance. Unlike traditional testing, where we follow a predefined steps, exploratory testing focuses on simulating unpredictable user behavior. But that's the challenge. Manual exploratory testing can be a tedious process and prone to human oversight. It's also limited by the creativity of a tester at a given moment. Today, I will introduce to a solution that bridges this gap, integrating generative in AI into exploratory performance testing. By combining the dynamic stable adaptability of AI with the automatic testing frameworks like Selenium, we can achieve this comprehensive, efficient performance testing. So let's explore how this works, its objective, and the transformative benefits of it brings. So, why exploratory testing? So, the traditional testing is an highly scripted and method, and it takes more time. For instance, we might test how fast a product page loads and how quickly checkout page and the button response. But how about the unpredictable ways the real users interact with our site? Like they may click around, they may make mistakes, and they explore parts that testers we don't often overlook. So exploratory performance testing tries to simulate this unpredictability by asking the questions: what if a user clicks on a rarely used link, and can the system handle invalid input gracefully? And this challenge is that this process has traditionally been manual and resource intensive. By integrating generative AI, we can bring in adaptability. So AI can dynamically explore the application and suggest actions based on the web page content, ensuring that we cover most of the scenarios. So, uh, what objectives we have in this is like, first, the idea is to make testing dynamic. Instead of having a predefined test cases, the AI observes the web page content and generates user actions in real time. For example, if the page has a sign up button, the AI must suggest clicking it, filling out a form, and submitting it. So, and secondly, the performance metrics are critical. while the AI performs these actions, we measure the metrics like the page, how long it does take to load, or how responsive is that click button, and how much CPU and memory usage it takes. Finally, we have we use the AI for not for just these actions, but also for analysis. After testing, the logs are fed back into the AI, which generates easy to read summary. So that's the objective we have in this workshop. So let's look at the key features we have in the system. First, we have a AI suggested user actions. This is where the GPT comes into place. It where it looks at the web page content and suggests actions like scrolling, clicking the links, typing into forms, or hovering over the elements in the web page. Next, we have the actions performed like the performance metrics, which are measured while performing these actions. Finally, the logs from the test are analyzed by AI itself. Instead of giving the raw data, we summarize the report, highlighting the slowest actions and the performance optimization needed, etc. So, this is an end to end process from generating actions to analyzing results. And if we move on to the code architecture, this is the flow of the program, how it works. Initially, we input the URL. It's basically an URL of the web page we are trying to analyze. And we have the WebDriver initialization. So we need to set up the Selenium, uh, which sets up the browser session and extracts visible content like text and titles in the page it has. And AI suggestions. This content is sent into ChatGPT, which generates a context aware user actions like the clicking on the page, etc. And next, it moves to the action execution. The Selenium then performs these actions, which is an automated framework like clicking a button or filling out the form. And metrics logging. Uh, During this execution, we record the metrics like response time and system resource usage, etc. And the next, this logs is driven into by a AI-driven analysis. At the end of the logs, it is sent into the GPT for summarization. So, what is the dynamic user actions we have here? So the system captures the title and visible text from the web page. For instance, if the page has an title like shop pets and visible text mentions like fish, dogs, reptiles, etc., the AI must suggest exploring each category. These actions are not predefined. So it is not any mentioned in the code or anywhere else. Instead, the GPT adapts based on how it observes, so and perform these actions in real time using the Selenium. This dynamic behavior means the system can uncover edge cases or issues that might be missed in the traditional method we use for the testing. So while testing, we capture three critical performance metrics like the page load time. This is the time it takes for a web page to load completely. For instance, a heavy product page might take more longer to load, and it can frustrate users. And the next point is metric we have is the action response time. This this measures how quickly the system responds to the user actions like button clicks or form submissions, etc. And lastly, the main point we have is the system resource usage. Here, we track CPU and memory usage to ensure the applications run efficiently under load. These metrics provide a detailed understanding of the application's performance, helping us identify the areas for improvement of the application. So after after the testing, we make sure the logs are created. Traditionally, this involves manually by combining through a raw data, which is a time consuming process. With the system, the logs are analyzed by the GPT itself. The AI looks for the pattern, anomalies, and trends, summarizing them in a human readable format. This automated analysis saves time and provides actionable insights for developers. So moving on to the benefits of this AI integration, the AI integration can have several benefits like dynamic exploration, which is the AI generates action in real time, ensuring broader test coverage. And it is efficient too. The automation reduces manual effort, allowing testers to focus on higher level insights. And then we have the scalability. The system can be simulate multiple users to performance under load. And then we have the comprehensive insights, where AI-driven analysis provides a detailed report highlighting areas for optimization. This approach transforms testing into a smarter and efficient process. So, though the system performs well, we have the challenges also. So, uh, first, it's an AI dependency. The quality of GPT suggestion based depends on the understanding of the web page content, and also like we have a cost management. The open API key, which is could be expensive, and when it is used on a large scale testing. And also we have the browser compatibility issues, where the system works seamlessly across every browser when we have the driver installed properly. And here we can have the future enhancements in this technology by enhancing AI prompts for more complex testing scenarios, and adding support for mobile and cross-browser testing. And then we can introduce real-time dashboards for visualizing performance metrics during testing. So I can now I will proceed with my live demo of the module. So this is my code, and we have the API key injected here, and
Even, sorry to disturb, but can you please zoom it so that
yeah,
everyone can, yeah, check it, what's written there. Yeah,
yeah, sure.
thank you.
And also we have the functions like the scroll, click, type, hover, the user actions we have in this we have added here. And let me run it once. So let me tell it before. So first, it's ask for the URL of any application. So let me take an URL of. Let's see, we can take an example of an Amazon. So we provide the URL of the application, and it asks for how many duration, like how many duration we need to run the test. Basically it's in seconds. So let me assume let me run it for a minute. So I give 60 seconds as a default. And we see here how many concurrent users we have. So let me give a 2. So basically what it does is the Selenium driver triggers the site here. And since it's a 2 user, it's running for 2 times. Just give me a minute let it run and complete. Yeah. So um, if you see here, right? So it gives the scenarios like check. It will randomly give you a scenario like uh, interrupt the load by page in navigating, closing the tab. It creates a scenario, how it can be used, and how well it can be tested. And here we have the advanced scenarios, everything, and the security and data protection. Here it generates the logs accordingly. And so if we need the report, right? So basically it gives the report here. The load time is average, varying from 3.3 seconds and 5.5 seconds and 6.3 seconds, and several measurement of CPU usage, like it varied from 77.9%, 76.1%. It varied like that. And error encountered was like uh, specifically a stable element reference, like since uh, this code need to be worked for every application, we need to enhance this part of the code such that the element can be referenced, element of an application can be referenced dynamically. And also we have uh, AI suggested actions, like several uh, suggestions are made for the exploration of the web page, such as testing the loading speed, all element functionality testing, and on different devices. Also, the average response time we achieve here is 0.02 seconds. So yeah, uh, this is the demo I have for this session. And let me move on to my PPT. So, to conclude, generative AI into exploratory performance testing transforms how we approach testing. It combines adaptability, scalability, and efficiency, uncovering performance issues that traditional methods often miss. So with this system, we move much closer to delivering applications that are robust, responsive, and user-centric. So thank you all, and thank you for GTR for giving me this opportunity, and thank you all for giving your time for to explain me this model. Thank you. Hmm. Looking forward for your questions.
Thank you, Ibn. Thank you so much.